Number 21 on the 12A, we've got a giant sequence here. Let's see if we can figure it out. Okay, non-negative integers AKM. This is a Diophantine equation, which means that, okay, we've got three variables, one equation, but we've got one other major condition, integers. Integers is the key here, non-negative integers. Okay, so we've got this kind of geometric sequence here. We're going to have to use the geometric sequence formula. That's 4 to the a times, okay, a times r to the n. R is in this case 4 to the k, right? Each time we're going up by a factor of 4 to the power of k. R to the power of n, where n is the number of terms. And if you notice here, we have, okay, let's say this is term 1, term 2, all the way till term m. And then let's say this is term 0. Notice that we have m plus 1 terms. So we have r to the n minus 1, a, all over r minus 1, 4 to the k minus 1. And that's the top. What's the bottom going to be? Let's write it in a different color. Very similar, actually, except we replace 2 with 4. It's the exact same thing. M plus 1 minus 1 all over 2 to the k minus 1. And notice, first thing to notice here is, like, let's just rewrite this. Let's just rewrite this as, I don't want to have to rewrite all of these things again. Okay, I'm just going to copy and paste. You won't get to do this in the real exam, unfortunately, but I get to do it now. And we can do another copy and paste. Okay, select and copy. Okay, and paste. Wow, that was so quick. It might have been quicker to write it out, honestly. Okay, we have this times, okay, divided by, we would have 2 to the k minus 1 all over 4 to the k minus 1, right? Because this is divide by twice, so we just move it on top. But it won't really matter because we're going to cancel stuff out anyway. So we have, okay, 2 to the a over here, 2 to the a, and then we have, okay, notice something really nice here. 4 to the k is 2 to the k squared. So we would have that, this is precisely, let's see if we can rewrite this. We would have that this is equal to 2 to the k to the n plus 1 all squared. Same thing here. 4 to the k is 2 to the k squared. We're going to be using this. Okay, so no here. We have something squared minus 1, and we have that same something minus 1. X squared minus 1 equals x minus 1 times x plus 1 by difference of squares. So we can just rewrite this whole entire thing as simply 2 to the k to the n plus 1 plus 1, right? By difference of squares. And similarly over here, we have the same exact structure here. Something minus 1, something squared minus 1. That's equivalent to just writing in the denominator over here 2 to the k plus 1. So wow, isn't that so much neater? We converted this to this, and now of course we have our 964. We can't forget about 964. Okay, so first things first, 2 to the a, okay. Notice this is odd. This is also odd, right? Because even, we add what? Odd. So odd, even, all of our factors of 2 must come from 2 to the a. So 964 is 2 times 482, 2 squared times 241. And we can see 241 is clearly odd, right? So 2 squared, this part is odd, so we know a has to be 2. A equals 2, right? So let's immediately just write that over here, 2. We're trying to find k and m. Okay, so now let's just say this is 2. It has to be 2. And now we can just say, we can just cancel out 2 squared from both sides to get, I'm not going to rewrite this, but let's just rewrite this as 241. And then we have this. Okay, now we're good, right? Because this is odd, this is odd. But still, 241 equals this. How are we going to figure this one out? So now you have to be a little bit smart here. Like, it's going to be a little bit of thinking, a little bit of maybe testing stuff out. But you want to be a little bit careful here. Or a little bit like strategic about how you approach this. 2 to the k, 2 to the k. That's the first thing, right? Okay, let's just say 2 to the k is a, right? We have a to the m plus 1 all over a plus 1. And this is equal to 241. Aha! This is exactly a factorization. And this is exactly going to be a to the m minus a to the m minus 1 plus a to the m minus 2 so on. It's just going to keep alternating. This is 241, where a is some power, a is 2 to the k, right? So a is 2 to the k, we have this kind of thing going on here. What could a possibly be? So here's like kind of the, we can just test out k. We can say, okay, let's test out a equals 2. Oh, well, that would require like, 8, and then, oh, that's going to be too large. Let's be a little bit strategic here, right? A to the m. This thing will clearly have to be bigger than 241, right? Because this whole part is going to be a net negative, right? Because this is a dominating term here. This is much bigger than any of these terms. So this whole part is going to be negative. So that means this is going to be greater than 241. We also know it's going to be a power of 2 because a is the power of 2. So let's say, I don't know, let's say we made this to be like 512. If this was 512, then we would have that the number is going to be, let's say this was 512. Let's say this was the maximum possible value for this is 256, right? It could be 2, depending on what a is. If a was 4, then we would divide by 4. If a was 2, we'd divide by 2. So this could be 256, 128, something else, right? The point is we're subtracting by something that's at most half of 512, right? And let's say we're subtracting the minimum possible value. If this first term is 512, the minimum possible value for this expression is 256. And then as we saw earlier, this is going to be a net positive because this positive term dominates over the rest of them, right? We're going down by a factor of a each time. All these terms are negligible compared to a to the m minus 2. So if this first term is 512, it's not going to quite work because this number is just going to be way too large. Similarly, if a is like, I don't know, 128, it's just going to be way too small, right? Because this number will be at most 128. It's going to be less than 128. So the perfect balance, here's the trick here. We want to say this is 256. Because we notice that, okay, this is our big most important term. It's going to be close to 241. These rest terms are going to be kind of slight negatives, right? We know it's going to be like, it's not going to be a huge negative because a to the m minus 1 is drastically smaller than a to the m, right? It's smaller by a factor of a. So it's smaller at least by a factor of 2, right? And then 128, like 512 would maybe just get to 256, but then you're going to be adding stuff later on. So that's not going to work. So a is just going to be smaller than a to the m. So this is going to be much smaller. We're really trying to make this term slightly larger than 241 and a power of 2, right? Since a is a power of 2, this is also a power of 2, this whole thing. So this has to be 256. And the question is, okay, we're dividing by a each time. How are we going to get 241? Well, let's notice something. 256, we're trying to subtract almost like 15, right? If you could just subtract 15, we'd be done. 15, that's almost 16. So what if we subtract 16 and then we add back 1? Aha, that's 241. And that's kind of the mindset that I went through when I was thinking of this, right? Because just approaching this whole thing is a little bit daunting, right? So first we expand it out. Then we noticed a clever trick, right? This is all kind of negligible compared to this. So like this needs to be just, even if this is 512, it would be too large. This needs to be just negligibly larger than 241, somewhat larger. So we see, okay, this is 256. And it's almost like we want this whole thing to be negative 15. And negative 15 is just negative 16 plus 1. Okay, so now let's backtrack here. Clearly, a is 16, right? Because we're dividing by a here. So a is 16, and m is also clearly 2, because a to the m. So and then a is 16, so that means k is 4. So k is 4, right, from that. K is 4, m is 2. We have our answer of 8. And that is a solution for this problem. A really neat, it's really not, even it seems so daunting at first. We do some geometric series analysis. This is really the trickiest part of the problem. Like getting to here, I would argue, is relatively straightforward. You just expand. Here's where you have to stop and think, okay, what do you do here? And the trick is, just the similarity. You then expand it out because we immediately see this factorization, right? And then we're like, okay, how can we cleverly approach this? Oh, this is going to be the dominating term. It has to be just a little bit above 241, and then we solve here. And that's it for this problem. I hope you enjoyed this video. Thanks for watching.